So basically what I would like to do is to show you some Python basic. The purpose of this talk is just to, because the most common language as I use on the computer science classes is C++, which programming in C++ it takes a very long time. It could be super fast. The Python is usually 100 times slower than C++, but it allows you to write programs much faster. The example that the difference of developing a system in Python and C++, which I know it was a very specific software written at Max Planck Institute for Theoretical Informatics, and in the C++, the team of one professor and two very good graduate students was writing the software for the 2 years. After that, they check if they could write it in Python. It took them 2 days. And the professor was, I heard it from the professor that did that. Okay, so basically there is the Python. So in Python, it's maybe the programs would not be fast, but you can write it very fast. So it's good for data science. It's good for working with the data, and this the one difference that is important, that Python is not not the language that you compile things. You interpret it in some kind of virtual environment of Python, in the so-called interpreter, and this is the main reason why it's a bit slower. But basically, you can just if you all open your Python notebook. I hope everyone could do that. And you just type Jupyter Notebook and open the notebook like I have here. So basically in the if you have any problem with setting up the environment, I can help. Okay. So basically in Python, even the number it would be a good expression. You would just return to the environment its value. So this you can write the numbers, you can write the strings, and we can print them out. The notebook are mostly used for working with the data, because you have the values of the environment, so you can load the data, you can do something with it, you can see the output of the beginning. You can assign to the value to the variable by just putting the statement here and name of the variable and just saying hello. So the variable s now, if I would like to print it, would have the value hello world. Okay, so this part we have done here already. But you can also define you can assign the numerical value, and you can add them just like in C. Of course, print it. You probably know this type of statements from C++, where you have some value, you add some other string, and then you convert everything to strings to get this right. So yeah, this will put the hello world to. If you would like to convert a string to the numerical value, you just use the function int. If you would like to convert the float, you just use the float. The one thing that might be that you probably noticed already, that we don't need to declare the type of the variable. We don't need to declare that, and this is great comparing to C. The other thing, if you make a division, you get at the very immediately you will get the float value. And this is maybe not very very optimal stuff. If you would like to get the integer value, use that to division. The other thing is modulus. If you would like to, for example, check if the 4 is divided by 2, you can get 0. this statement. I put this statement on purpose because we, if you, for example, have a very long loop, you can use it to check the condition at some point. And of course, you have the value true and false, which in C is not declared, but and of course true is not equal to false. Okay. So basically, the one of the most powerful features of the language, which allows to very fast developing stuff. If it's too basic, please tell me, and we can go to more advanced stuff. But basically, the open you can declare the list. The list is the sequence of values, and they could not be the same kind. So you are not forced to have the list of integer values. You can put the strings inside too. So basically, there is a list of you can define the list like that. Get printed like so it's 1, 2, 3, 4. You can define the next list, which is 5, 6, 7, 8. But you can add those two lists together by just simply put the list plus list 2 equals list 3. So then sorry, I will just move it up. So then you can just have the whole list.
Oh, you printed 13. Okay.
Yeah.
Let me see. I want to see. Now, if you want to add them like vectors,
Well, basically,
because essentially what you did is you enlarge the array.
yeah, I'll learn.
Put in the next array after the first array. Right? Is that what you did?
Yeah.
But let's say instead of that, you wanted to add the two arrays. How you add the two arrays?
Basically, this would be. I can do it either by using some kind of a loop to do that, or writing a function to add two lists together, or I can use the NumPy package. I did not put it here in this presentation, but I could add it. It's not a problem.
No, I mean just.
But basically, the NumPy is better suited for the vector operations than the core stuff.
That L looks like a 1, but it's actually an L. Yeah.
Sorry.
I'm saying because.
Which one? Where is L and where is 1?
L and 1, it's the same exactly.
Yeah, they look exactly.
In this font. Okay, as I promised, there is a possibility to have the different types, so we can have a string in our list. The second thing that might be important is generating the list of the same elements. For example, I have the list that have only one element 0, and I would like to multiply it 10 times. So I just write 10 multiply 0, and I get the very long list. You can put any value here, which could be 1.5, and it would be given like that. But if I would like to refer to the value in the list, for example, to index 1, I get one. I just write the square brackets and I get the value from it. So this might look familiar to you from the C++ point of view. But I can assign the value to the list by just referring to the index and putting a number there. I can just replace the value. What I get here is just I got the 5 on the index 1. You probably noticed by now that the lists are indexed from 0. From 0. So I can just add another element on the position 6, and I will have here I will have the. But what I can do also.
No,
is,
I'm confused.
Yeah.
Because the first element of the list is 1.5, and then you assign the value 5, You print it again, it comes out second.
Oh, it's zero
Yeah,
index.
it's zero indexed R.
Oh, because the other one is here.
It's 0, 1, 2, 3.
Okay,
Yeah.
okay. Yeah, that's what's confusing
Yeah.
because either 0, 1, or 2, they're all 1.5. Okay, thank you.
Yeah, okay. If you can also delete the element of an list using the del operator, but I find it quite nasty way. You can delete the element 6, which was 75 in this case, and you notice that it shrinks. Well, the lists are indexed from 0. And if I would like to append the element, one element I can just write append line or something like that. The one of the very more extremely important statement which I'm using very often is the length of the list. So it's just you put len and the list. The other stuff that will come handy when you work with the with some sets, it's slicing. If you have the list which is from 0 to 9, you can make easily a slice of it from 0 to 3. So get this is the starting index, and this is the first index that would not be included. So from 0 to 3 it means only 3 first elements, but you can also make a part of it from 2 to 4. I hope that I'm not going too fast for you to write the code. But also you can say that you would like to start from the very beginning to the element 7. So you just put the list, square brackets, and semicolon here, and the index that it should reach. So you get only first 7 elements. But also you can say that I would like to add 3 elements from the end of the list and use the minus indexes. So this might be a bit confusing, but sometimes it helps. The next feature that I would like to show you, which also came handy in programming, which in C I need to scan the whole array if I would like to find if the elements is in the array. In Python you can just check it if the 2 is in list 5, it's true, or 5 is in the list in this list. Well, it's not included, so the reason is false. Okay. The other stuff that is good about list, and they are maybe not the best for the mathematics, but it could be, is that you can have you for example can define you have some list, and you can sort it by just writing. If you just do it, it sorts. But one thing, if you use the notebook, one handy feature is that if you have a list, for example, you write a dot, so you would like to invoke some kind of function on it, you can just put the tab, and then it shows you what are the possibilities. So this is which sort is one of the possible solutions. So you can get quite sorting quite easily in this case. And there is, of course, you can run some statistics on this list by just using getting the minimal value, getting the maximal value, and stuff like that. One thing that I would like to, one thing is important. If you have some kind of object, then you can invoke some functions from it by just putting the dot, and you can, for example, insert the element or use something which is called pop, which remove the last element from the list.
What's pop?
It removes the last element from the list. So now it's only 1, 2, 3. The idea standing behind the pop is that you can that you can use your list as a stack. So you can add the element at the end and remove the last element. And you can also iterate over the list. So you can say that I would like for X in the list. So you just go over the elements of the list. I would like to print all the elements. If X, it's something similar like the algorithm for each from the C++ library, from std library, from algorithms. So just print all the elements like that. The other stuff, if you, for example, would like to create a list of the specific value, for example, a square roots of only even value, you can say that list L it equals the square brackets. You define some kind of for statement for E in range. Range is generating you the values from 0 to this value, except the last one. For 20 values from 0, so it would die on the 19. So here you define what is E. You can add some statement if E is even, then it would be true. So this value would be passed here only if the E is even. So then you can make the comprehension like that. So you have the square roots of the all even values up to 20. But you can also remove this statement here, and still will be perfectly value equation. So for all E in range to 20, you will get the square values.
Where is E from?
E is taken from here, from for E in range, and it's passed here. It's maybe more common. It would be that if it would stay here, but this is the expression, and here is the range that you've taken it from.
You're declaring E in that for statement.
Yeah. The other important part is loops. So if you have the list from 1 to 5 and you would like to iterate over it, you just do you just say that element is in the list and you would like to print it. You notice that I use that there is no brackets, like I don't know, curly brackets. Yeah, it's called. But you just use the tab, and tab means that this statement will be below it's a part of this block of code. In Python, you use tabulation to get for the curly brackets, and the tabulation is very important, because if you don't have the tabulation correct, your interpreter might say that it's all rubbish and he is refusing to cooperate. So but you also can iterate over the range. For E in range 10, print E. The other stuff which I learned, I would like to know it from the beginning, is enumerate. If you, for example, have the list L, you can get the element from the list, but also the index of the list. So then you can do something like that. On the index 0, you have 1, 2, 3, 5. So this is the index of the list. This is the value of the subset. The other stuff is that you can, as I mentioned, you can make you use the tabulation to show that something is below the code. So if you can make the two statements for E in the range L and for J in the range from 0 to E, print a star. And I don't want to, usually the print statement ends the line, but I can say that do not include to change the ending of because the print add to everything that is printed closing line. So I can say that ending would not be a closing line, but it would be nothing. And at the end of this for loop I would like to print to indicating that I'm closing the line, so I get something like that, basically. So it's using the double for. I assume that there is also in Python while statement. So you have some condition that you say that this statement is going on, and you just add and check after every if this condition is satisfied or not. But you can also make some more bizarre constructions. For example, while true. While true is usually used in the servers because you start the server and you don't want to end it, never, or maybe only under the central conditions. But and we start from I equals 0, then we would like to print it, and then we would like to add 1. You're probably familiar from this statement from C++. And if the I is greater than 10, we would like to break. We would like to go out from this. So we just make we just going out from this loop out. In Python there is also continuous statement, but I don't know if it would be maybe not this time. Okay, so if I do not lose everybody by now, maybe the other stuff is the conditional statements. Okay.
So I know Python, so
Oh,
a little bit. Some of the earlier stuff. This is okay.
okay. So basically, if you would like to check some condition, you can use the if statement. If some statement that should provide true or false. If it's equals 1, then print 1. If else, something else than 1. But if you, for example, give here x is equal 1, then so right. You can also make the condition. Usually in C++ you have ifs, and there is a statement with many ifs. There it's tricky. If you have the second if, you put the L if, and then it would stop on the first if that would be matched. So here you can greater, or if they are equal. So basically you can. There is one of the Python features that might be interesting. Is that you have something which is called none, which means nothing, and this is not a class. This is just nothing. So something like a null operator in C++. I assume that you all know at some point C++. Okay, so okay. Okay, so but basically none means none. It's nothing. It's also false. And if you put you can make the comparison if x is equals none, and it gives you okay this in this case. But also you can say that if x is none, and this will also will be perfectly good statement.
I'm sorry, none in Python has no value, it's just
Yeah.
okay. Is it like null?
Yeah, it's like null.
Okay.
For example, one thing that you could do is if you have, if not, what you can do if none. Basically, none have the value of false. So this if none, it would say it would be transposed to false. So, but basically, but this is I think the same would be with 0, and the same would be with empty brackets. But if you have anything here, this would be true. So this is some kind of C-like stuff. Okay, if you have any question, if I should be going slower, I should be going faster, please let me know.
Can you go a little bit slower?
Okay.
You can't jump
Okay.
into
Okay.
the first one.
Okay, so that's
Just a little bit.
okay. Okay, let's go to the other stuff that might be important is the printing statements, and there is a huge difference between the and the strings. There is a huge difference between Python 2 and Python 3. In Python 3, it's a bit easier. Basically, if I have the some kind of string, and this was the numerical value, but if you would like to transfer anything to string, you just put str an object, and it should work. So here it's test none because x was equals none in the previous. It was say that it was none. Okay, basically, if you would like to print something, you can just put print and add the strings together. But this is not a very nice way. This is a very ugly stuff. But sometimes I do that because if I had to write something in 15 minutes or something. A bit better way is this is a C-like. You can just say that I have some kind of formatter here, and I say that I would like to put a string here, string here, string here, and maybe some decimal stuff. And I have some kind of percent sign and some kind of and brackets, and I put something like list here. But this is a bit better, a bit easier to understand. But this is not a stuff that I would like you to use. Nice stuff is, for example, you have the some kind of assignment. You have the variable ugly, variable stuff, variable action, and some kind of number here. And you can compose the string that it's important to put the f here, and you can say that I put here the variable ugly, which will be transferred to the string, variable stuff, action, and something like that. And I can easily compose the string out of it. And this formats you a string very fast. And you can see what variables did you use here. I will send everybody the notebook on so we can. Okay, so do you have any question to this part? Okay, the biggest feature of Python is that you can import. You have the humongous number of libraries to use. The one of the and you import them just by saying import math as m, or you can just do the import. It's usually better to save the library on some stuff that you remember not to write. So we can just import a mathematical library, and we can call the function from this mathematical library. Let's make it a square root. And we can just get what someone else. I think that the most important, the most that we use Python for is plotting. So there is an excellent plotting library called matplotlib, and some kind of sub-library called pylab, and we can just import matplotlib.pylab as PLT, and then we can generate numbers from 0 to 10. And we can generate the square roots of those numbers here using the comprehension. Then what we can just do, we can just say plt dot plot if x y. I put some optional label here, information, but basically what we could do to get the easiest possible plot is just to write plt plot xy plt show, and this is all to get the plot.
Can you go down in the notebook just a little bit? Or further up, sorry. A little bit more? Yeah, I just want to see what, okay, now you can go back down.
But basically you can do far more with this library. You can just to plot just give the label if you need to print multiple functions. For example, you would like to plot another function which is plot x label like that, and you can make the legend, and you can describe the and the colors are assigned automatically, but also you can assign them. It's not a problem.
So in Python, since instead of using curly brackets, you use tabulation, would it still be best to put your libraries at the heading of the code?
Yeah, it will be. But this is there is many sections here in this notebook, so I don't want to put all the includes at the top.
Okay, just make sure.
Okay. Okay. The other stuff is defining functions, which you can define something that you can use later on. You can just use the keyword def, the name of the function, and the number of variables. You can put multiple variables here. If the function could get one variable, none of variables, and many more. And you just put the return statement to what you would like to return. You can put a lot of code here between, but you need to finish with the but return statements you need to add if it has to return anything. So you can also make the function square of a, and you can if you put this short description after the name of the function, what you can do, you can just make help write help sqr, and it's not a part of module, sorry. Apparently I missed something. But basically you can use the keyword help to access the information about the libraries. For example, we define the PLT library, and we can get the information about the module, all the functions and stuff like that. So this is a sum. How we are with the time? 20 minutes more.
Are you gonna send the notebooks?
Yes.
Or post them so
Yeah.
everybody has access to
Yeah.
the notebooks?
Can I send them through the non-Pueblo WhatsApp list, or should I send it by email to some of you? Email, okay. Okay, the other funny stuff is tuples. They use the
Adam, I don't have the names of everybody that is here. I think everybody's here, are in the WhatsApp group. Probably we don't have the emails of everybody that's in here. Am I wrong?
We don't send emails to some people here.
That's my point.
Yeah, we can get their emails.
So Adam has it to send. I mean, my point is, be sure to send it to everybody.
Just pass it around to whoever doesn't get regular emails from us right now.
Oh,
I guess not, it's not.
I think it's mostly, not that we wanna put you in the spot.
We're putting in this.
okay. The one thing that it's you remember the lists, but there is also something called tuples, and the lists use the square bracket. This use the normal brackets. The only difference between tuples and lists that you cannot change the value in the tuple. And this sometimes it's important to have this feature. But for example, you define the tuple like that. You can refer to the index of the tuple using the same as the lists. But if you try to change something, you'll be warned that the tuple object does not support the item assignment. Period. There is nothing you can do. And you can add the tuples together to create a bigger tuples. So this was just for mention. One feature which is extremely this is something that in my opinion speed ups the coding pretty much is the dictionaries. In the dictionary you have the value, you have the key, and you have the value. And there is no predefined set of keys, and as you go you can add the pair's key value to the dictionary. So you can dictionaries are defined by the curly brackets, so no brackets more to define for the items in Python. And it's usually that you have the key, semicolon, and the value of it, and you can have the different types of the values in the dictionary. For example, you can have the name, and you can have the some kind of, I don't know, range in the megaparsecs how far we can go, and you can refer to the value of the dictionary by simply putting the name of the dictionary and the key value, or you can get but you can also there is no site assignment, so you can just give the key site and the value CTMO. And it will be added here. But if you, for example, I don't know what we Macon, but already we have this. It would be
Why
updated.
with two C's? Why with two C's?
Oh well. What does it mean with the two C's? There is some.
Just because you put two C's.
Okay.
Why two C's?
You don't want to know.
Okay. Okay, but one thing that you can do with the dictionary is to get the list of keys, list of values, and so this is and also as I, if you have the dictionary, you can put dot and you can see what you can get from it. You can get items, and then you get the pairs as a tuples list. And of course, we did not define in this dictionary coordinates. We did not, and if we use the statement the coordinates, then we get the error. But if we use the function get, we get none. And usually this function allows you to define what to return from the dictionary if you have no information about this key. The default is none, but you, for example, could put some kind of safeguard. It's usually easier to put the get something than to check every time if the value is in the dictionary. Okay, files. With files, it's a bit easy because you use the keyword open to name of the file and the mode that you're opening it. So you get the handle for the file. You can write the new line you would like to write a number from 1 to 10. This is and you need to close the file. Please close the files. This is something that there is a certain number of descriptors in the operating system. Now it's about, I guess, few millions, but there is a finite number of the files that could be open. And this matter only on the supercomputers if you have too much files open, or if you would like to make a logical bomb for the Unix system, which is some kind of a typical assignment on the operating systems to overload the possibility. And
You're talking about like if you're in the context of having to write lots of data,
Yeah.
different files.
Yeah, but you can also use, and this is the easier way, in my opinion, to deal with files. You can use the keyword open with something, with this statement as defined, the result of this statement defined as f. You can do multiple things, and at the end of this, the f vanishes, so it would be automatically closed. So then you don't need to think about closing the file or something like that. And we can read the lines. But this is a bit ugly because in the file there was 0 and the line, 1 and the line, and this is not as stuff like that. I would like to pause here for a minute because there's one more thing I would like to show you, which I hope would make the handling files a bit easier, maybe. But I need to open this separate. I need to open a terminal to do that. Oh, I see. I use this. Okay. Maybe this. Okay, maybe this is a bad idea. One thing that it's if you use, for example, imports for L, you can use the system library for L for line in the std in. You can just print. Okay, so I just, the script that I have in this window, here it's supposed to get, it should get the line from the standard input, line by line. It would iterate over the line getting on the standard input, and would just print them with adding the exclamation mark. So I just run this script in the Python. It's test to py, and put the some text file that I have. I forgot to save it. Basically, by using this statement for in is std in, you can iterate over the files that you get on the standard input, and this is extremely useful in the Unix operating systems because you don't need to care about reading the file. This helps if you have only one file to read and you need to process that. Okay, sorry for. Okay. One more feature that I would like to show you, just to show how the Python could be used, is we have this list of the file that we get. There is a 0 end of the line and stuff like that. We would like to iterate over it. Well, the way that you probably think at this point is to use something that we learn. For example, we have the list, which is we can do for element in lines, we do LL append. We are adding to the and we put the int for this element. And this will work. We get perfect clean list of numbers. And this is the stuff that we already touched today. But what we can do is something called functional programming. We can use the function that takes as an argument the other function and apply it to every part of the list. And there's this function is called map, and you put some kind of keyword which is lambda. It means that for x we create a function that we do not give the name x, and this x should be converted to int. And the second parameter of map is the list that we would like to iterate over. And because the maps in the Python tree is a lazy expression, we need to make we just put here that we converted it to the list. So we can do something like that. Sorry, this might be a bit confusing. It's confusing stuff, but it sometimes helps. I just wanted you to know that you have stuff like that in Python. The other one is the filter option. And for example, we would like to have lambda x. X is only even number, so we put like that, and we would like to have a new lines here. This of course will give us, as I said, it's a lazy statement without, we need to force it to do something. But we only have the values that are, I just wanted you to know that there is a feature like that in Python. In fact, in Python you can do, in C++ this is a procedural or objective language, but here you also have the objective paradigms in Python. But also you can do the functional programming. You can pass the function as a parameters, and you can return function as a results.
Because the function itself is an object.
Yeah. This is the key. And one thing the last thing that I would like to close is that the Python is battery included stuff. So basically, if you, for example, have the Astro Query library, and you would like to query some SIMPAD catalog, there is a whole big library to access the astronomical data, which is from the catalog called SIMPAD. I just go to this. I do not see anything here. Okay, I will maybe show it. But we can just make and we import from SIMPAD we import SIMPAD, so object to deal with the catalog. And then we can do SIMPAD, invoke the function on this object, query object M1, Galaxy M1, and we can get the information about the objects. So the main ID, rectastem, declination, and but here is a lot of stuff that it was not shown. Yeah?
I have a question about that. When you're returning a table, how do you expand the table?
You can get the keys of the table. For example, this is some kind of
So you use, what did you use for that?
I just asked to print the object.
Okay.
The other stuff that you could do is just to get ask for a columns, and you get the list of columns that you have, and you can iterate over the list of columns and get the value for. We could do that. The other stuff, we can query all the stuff that is in SIMPAD between those coordinates with the 5 arc-minute radius. So you can just do that and get the information about all the objects. And basically, what the one apart from that you can write the code fast, the Python have a lot of libraries to use, and this is the main strength of it. So, but So there is libraries for astronomy, there is libraries for mathematical application like NumPy and SciPy, signal processing. There are ports to NVIDIA CUDA if you would like to use graphical cards to work with that. So there is a lot to use. I hope that this was just a pure show what could be done with it. If you would like to get more information, the one thing is some kind of reference is the tutorials point Python 3, and there is a lot of stuff included. The other stuff, if you would like to study Python, it's learning Python the hard way. There is, unfortunately, this is the web page, or it's not what.
The name is funny.
Learn Python the hard way. Yeah. But basically, I think that it's you need to pay to access it, so it's better to just do the stuff like that, and you get the book itself.
Everything is on the internet.
Yeah, and if Google will remove it, try Bing and other services that still search the.
Or just download it really quickly.
So basically, the other stuff, there was one book which was dive into Python, but I have some hesitation over it because I do not find it. For me, it was not a good one, but maybe for others it will. It's quite good comprehensive guide to Python. What?
The pink Floyd quote?
Yeah.
Pink Floyd. I love the quotes. Okay. Oh, but with the books, the books that are worth, if you will be if you would be doing some big projects, the one of the classical books from project management, yeah, this one, sorry for the other stuff. Edward Hjorgdon, this book is really great. Sorry, I'm sorry.
I'm sorry, I was just laughing.
Yeah, this okay. This book is the best one for doing projects, and it was the. But this is for a big project that you have about, I don't know, 15 people, and you have that strict deadline, resources to use, and it's basically how to avoid the problems with developing a huge IT project. And this one is useful. And if you anytime if you would be thinking about applying, I don't know, for the job to Google, this one, this book is to read before the interview for Facebook, Google, and other stuff. It's cracking the coding interview. Basically, if you can do all the examples, it should not be very hard. And you need to also know algorithms and stuff like that. But this is a good one to read if you are applying for the IT job. And this, I think now it's the 6th edition or something. I bought it with this edition. So, and this is okay. So, and if you will be doing the data science, there is a Kaggle which hosts the contest for solving specific tasks, and also they have the data sets to try for the data science. And now it's what are the currently oh, there is LSST LSST contest to classify the galaxies. There is, but there are some other projects. For example, on KGO, the funny stuff is that sometimes there are cash prizes for the contest, but there is a lot of people on that money. So but you can get the data sets. You also can get the stuff connected, some tutorials for Python. And they have tutorial 7-day Python challenge, which is quite good. Yeah, so basically this is all that I wanted to show. Thank you very much for your attention, and if you have any questions, please don't hesitate to contact me.